Hi there everybody, today we're going to look at angles in polygons, specifically sum of interior angles, and see how that comes together. There is another lesson about sum of interior and exterior angles that we're going to go to, but this is more specifically about some of bigger shapes other than triangles. Alright, so when you're thinking about a polygon is any shape that has straight sides. You'll come across triangles and quadrilaterals in terms of the angles within those. But what happens if the shape is bigger and you have more sides and you're trying to figure out the angles inside those? So there is a rule to kind of go with that, which we want to look at. So we're going to look at a bigger shape. So here we've got a pentagon, five-sided shape, and we want to figure out what the angles inside there all add up to. So when I'm talking about internal angles, that's these ones inside the shape. All right, so inside the shape. And find out what. Well, if it's a triangle or a rectangle, then we won't have a problem. But because it's five-sided, obviously it's more sides and therefore more angles. So, in order to kind of figure out the rule, and this is what we're going to look at, if you pick up a corner, you can split up any shape into triangles. All right. So we split the shape up into triangles. You can see line down there, and it forms 1, 2, 3 triangles. Okay. So we know that these three angles are 180. We know that these three angles are 180, and we know that these three angles add up to 180. So what you've got is 3 lots of 180. All right, 3 lots of 180. So that means that all these angles inside this pentagon add up to 540 degrees. All right, 540 degrees, and that works with any shape. I mean, you could take an octagon or a dodecagon or a bigger shape with lots more sides on it, and from there. Split it up into triangles from one particular point and then see how many it needs to add up to. But of course, in the exam, that's the last thing you want to be doing. You want to try and find a quicker way of doing it. And of course, this is about spotting the pattern. Well, the pattern is the idea of saying, well, if you've got a five-sided shape, it's 380s. If you have 3-sided shape, it's 180. If you've got a 4-sided shape, it's 280s. It's always 2 less. And that is a rule. Okay, so there are 2 fewer triangles than sides, always. All right, so if we're going to write a formula for this, or of interior angles, then I would say n, which is the number of sides, take away 2 less, times 180, and that was going to give me my sum of interior angles, the ones that add up to. All right, so n is the number of sides. So here's an example. So if I have to find the sum of all the interior angles of an 11-sided polygon, I'm going to take away 2 from the number of sides, and then I'm going to times by 180, and I can tell you that all the angles in an 11-sided shape add up to 1,620 degrees. All right, and that is the rule. All right, so that's what you need to kind of take away from this. It's always going to be 2 less. Okay, so another way to kind of think about it, so you calculate an interior angle in a polygon by dividing the sum of interior angles by the number of sides. Okay, so the key bit here, the interior angle of a regular polygon, well, a regular polygon is where all the sides and angles are the same. All right. So if I ask you to work out the interior angle of a regular octagon, then I'm going to find out what they all add up to. Okay, and then divide it by 8. All right. So I'm going to do an 8-sided shape. So that's going to be 6 lots of 180. It's going to give you that, and they're going to divide that directly by number of sides because they're all the same. And that's going to give me 135 degrees. So that angle there, 135, 135, all these angles inside the shape add up to 135 degrees. Okay. Well, there isn't a lesson on exterior angles, but of course in the question it does ask me the exterior angle. But essentially, exterior angle is when I draw a straight line down here. All right, that angle there would be classed as an exterior. All right, so if I draw a straight line from there, that would be an exterior angle. If I drew a straight line from there, that would be exterior angle. And actually, when I say talk about straight line, that means that one plus that one is going to add up to 180. So it's quite straightforward. The exterior angle is 180 take away 135, which is 145 degrees. All right, so that would be my exterior angle. Since we're here, I might as well say there is an easier way of working out an exterior angle. Exterior angles in any shape add up to 360. All right, so they add up to 360, and because they're all going to be the same, I can just do 360 divided by 8, and that's going to give me 45 degrees, the same thing. All right, so it's a quicker way of achieving it. So again, there is another lesson on interior exterior angles in relation to this, so please do look at that one. But since we're here, I might as well mention it. The one final bit that I want to talk to you about is tessellations. Tessellations are when shapes fit together perfectly to form gaps. All right, so thinking about bees and all the honeycomb kind of shape, well, these tessellate. You can see that all the shapes kind of come together. And actually, there aren't many shapes that come together like this. And the reason there aren't that many shapes that come together like this is because these angles inside here, because it forms a nice little, basically, circle, they need it to add up to 360. All right, so that plus that plus that must add up to 360. And the only way that's going to work if those three angles there are both or all the same. All right, so that means they need to basically divide into 360. So to form a tessellation, interior angles, that's these things inside, it must go into 360. All right. So when I take this particular example, it's a 6-sided shape. All right, so thinking about what we've just done, so that's going to be 4 lots of 180, which is 720. So they all add up to 720. Because it's irregular, then divide that by 6, and that's going to give me an angle of 120. 120, 120, 120 gives me 360. Hence it tessellates perfectly. All right. So here's a question: does a 10-sided shape tessellate? All right. Well, that's going to be 8 lots of 180, which is 1,440. Well, because it's going to be a regular one, and again it says here regular, divide it by 8. No, sorry, divide it by 10. I should say it's 10 sides, isn't it? Divided by 10, and that's going to give you 144. Well, does 144 go into 360? Nope. So that does not tessellate nicely at all. All right. Okay. Well, please do go back to maths-school.co.uk. Link is at the bottom as normal to do a bit of practice on this one. Like I said, I've mentioned a few other lessons in terms of interior, exterior angles, so please feel free to visit those as well if you think you need to. Thanks for listening.